So this is going to be just a quick video about radians and converting between radians and degrees. Remember that degrees are how most of us are familiar with measuring angles, if we have an angle like this, well, that looks like it's about a 90-degree angle, assuming I can draw a straight line. And something like this is 45 degrees. That's how we're familiar with angles. When we get into trigonometry, we have ways of describing angles and measuring angles other than degrees, and that way is radian measure. The example I used in class was if we had a circular lake with a radius of 1, and I walked around it. So at first I was at 0, and if I walked the complete way around, I would walk a distance of 2 pi. Remember, the circumference of a circle is 2 pi times the radius. So if the radius is 1, then the entire circumference is just 2 pi. Halfway around would be pi. Halfway between 0 and halfway is a quarter of the way, which would be pi over 2. So down here would be 1.5 pi, or 3 pi over 2. And then we can break these down in even smaller segments. So here, half of a half is a quarter. So this is pi over 4. We could look down here and say, all right, well, this is going to be pi over 6. If I broke it down into thirds, this would be pi over 3. Another third would be 2 pi over 3, obviously leading to 3 pi over 3, which is pi. If this is pi over 4, 2 pi over 4 is over there. 3 pi over 4 would be there. And then just a sliver less than 6 pi over 6 would be 5 pi over 6. These are the common ones, and of course they go down into quadrants 3 and 4. You could have radian measures in really anything. You could have pi over 7, pi over 8, pi over 9, etc. You could have 1 radian. But these are the common ones we remember because they give us some nice points to deal with, some nice values that hit the circle here. For example, pi over 6 hits the circle at root 3 over 2, comma 1/2. Pi over 4 is at root 2 over 2, comma root 2 over 2. And pi over 3 is going to be at 1/2, comma root 3 over 2. Remember the pattern that I showed you. X's, the cosines, are going to count backwards from 3, 3, 2, 1. And the y values, the signs, are going to count upwards from 1, 1, 2, 3. And that pattern goes all the way around the circle. Now, let's say we have some sort of a radian measure. So we're going to convert this to degrees. So, let's say we have pi over 5 radians. We want to convert this to degrees. We're going to use a conversion factor. So basically, we're going to multiply this by 1 and end up with degrees. Now, in order for us to multiply by 1 and end up with a different unit, we're going to have to cancel out. So in my denominator here, I'm going to put pi radians. In my numerator, I'm going to put the unit that I want, which is going to be degrees. I use 180 degrees because, again, 180 degrees, a straight line, gives me pi radians. You could choose another value. You could say pi over 4 radians over 45 degrees because they are the same thing, but that's really complicated. This is nice and easy. And actually, when we multiply this, we can see the pi radians drop out, and we're left with 180 over 5. And so we can reduce our fractions as we always should. And let me choose blue. That would be 180 over 5, which is 36 degrees. That's nice. Let's go the other way. Let's go from degrees to radians. Here, I'm going to choose a more straightforward number, something maybe we don't have to reduce. I don't know. I'm going to make this up off the top of my head. Let's say 41 degrees. And in order to multiply this or convert this to radians, remember 41 degrees is 41 degrees over 1. We can make anything a fraction. Now I'm going to put degrees in the denominator and radians in the numerator, the inverse of what I did before. The reason is because now when I multiply, degrees cancel out with degrees. And here I get 41 pi over 180 radians. There's no need to reduce or anything. Believe 41's prime. I should know that, but it's the weekend. Who remembers prime numbers on weekends? But anyway, the important part is that we can reduce, or sorry, not reduce, but to change between degrees and radians and understand exactly what a radian is.